Hello students, welcome back. As we were discussing definitions that were related to sets in previous lecture, in this lecture we are going to study what are the operations that are related to sets, or what are the operations on sets. So let's get started with this. First of all, the first operation that we are going to learn is the union of two sets. Now union of two set, what is union of two set? So if two sets are given, a set can be formed by using all the elements of two sets. Such a collection is called the union of the given set. Now what does that mean? Further it says that union of two sets A and B is the set of all elements which are in A or in B or in both. In symbols, we used to write it in AUB for the union of two sets. So this is particularly, this U is particularly the symbol for union of two sets. Now it means, okay, let we have two sets A and B. So we're going to combine the members, the elements of two sets, and we're going to write it as one set, or as it is written out here, or just let's just take an example and understand it better. Okay, so here we have a set A which has element 3, 4, 5, 6. Then we have set B which has elements 6, 7 and 8. And then we have set C which has element 8, 9 and 7. Now, if I wanted to calculate A union B, what will be my answer? So A union B means that we are combining all the elements that are present in set A and in set B. So the answer will be 3, 4, 5, 6, 7 and 8, where 3, 4, 5, 6 are from set A, 6, 7, 8 from set B. Now the point out here is that element 6 appears in both the sets, but we have written it once. So since that element is repeating, that doesn't mean that we need to write it twice. We are only going to write it once. So we don't have to repeat elements if they have common elements in two sets. If there exists some common elements, so we don't have to repeat those elements. We can just write it once. So this is the union operator. It works like that. So let's say we have another example, or if B union C is asked, so what will be my answer? So B union C means the B set has elements 6, 7, 8, whereas C has elements 8, 9 and 7. Now as you can see that element C has no order. We can write it in order, we don't follow any order, it doesn't matter. So B union C has elements 6, 7, 8 and 9. The same logic comes here, that if there are certain elements which are repeating, now we can see that in B and C there are two elements common, that is 7 and 8. They both are repeating, but they are written once. So when we are using union operator, we are only going to write it once. We are not going to repeat letters only because these two letters appears in two different sets. Or we can say that these two elements, because it is appearing in two, these elements are appearing in two sets, that doesn't mean that we have to write it twice. We can only write it once. So that is the rule out here. We don't need to write it twice. If it is written, if it is repeating, we're just going to write it once. That's it. Let's say if someone asks you for A union C. Now there is a case out here, there are no elements repeating out in these two sets, that is set A has element 3, 4, 5 and 6, whereas set C has elements 8, 9 and 7, and they are not repeating at all. So we just write it, we combine them together and form one set. So that is how union work, the operator union work in sets. I hope it is clear. So we are moving on to our next operator, that is the intersection of two sets. Now what does intersection of two sets means? That means, let's say a set can be formed by using all the common elements of two given set. Such a collection is called the intersection of the given set. Intersection of two sets A and B is a set whose element belong to both A and B. In symbol we can write A and B for the intersection of to set A and B. So this particular symbol, this N, is the symbol for intersection. Now it says clearly that in intersection we are only going to form a set of using the common elements present in two sets. Let's say that we have three sets here also. We have set A, which has element 3, 4, 5 and 6. We have set B, which has element 5, 6, 7. We have set C, which has elements 7, 8 and 9. So if someone asks me what will be the intersection of A and B, so A and B, as we can see out here that the common element present in set A and B are 5 and 6. So according to the intersection operator, we are only going to find out, we are only going to make a set of the common elements. So the common element in these two sets are 5 and 6, and that is my answer. Let's say if someone asks what will be the intersection of B and C. Okay, so as we can see that intersection means that we need to form a set by using the common element present in two sets. So if you can see in set B and C there is only one element common, which is 7. So B intersection C means that a set is formed with that B intersection C means that we have only 7. Since we have only 7 common, so the answer is set 7. B and C is equals to a set which has element 7. Okay, moving on. Okay, we are moving on to a next operation, but before that we need to know that what are disjoint set. Now let's say, as earlier we were talking about intersections, right? Okay, intersection, that means that we need to have elements intersecting. Intersection operator works like that. We only form a set that has common elements. Okay, let's suppose that if there comes a condition when we take intersection of two sets and there is nothing in common, then what will happen? The result will be a null set. And if the result is a null set, then such sets are called disjoint sets. That two sets A and B are said to be disjoint if their intersection is a null set. Let's say we have set A which has element 1, 2, 3. We have set B which has elements 4, 5, 6. Now if I take intersection of both the sets, the answer will be a null set, a phi. So when this kind of a situation occurs, we say that it is a null set, or sorry, we say that it is a disjoint set because it has nothing in common. Moving on, we're now going to study what are the difference of two sets. Now, difference of two set A and B, that is A minus B, that is somewhat the difference means the subtraction, is a set whose element belong to A but not to B. A minus B is called the relative complement of B with respect to A. Now what does that mean? First of all, let's take an example. We have three sets out here. Set A has element 2, 3, 4, 5, 6, 7 and 8. Set B has element 1, 3, 5, 7 and set C has element 2, 4, 6 and 7. Now if I wanted to find out the difference between the difference of two sets, that is, let's say we need to find out A minus B. Now according to the definition, it says that we are going to subtract subtract the members of B from A. Let's say we need to find A minus B. So the result, as we can see out here, is 2, 4, 6, 8. Now how it works, how subtraction works, the thing is very simple, that if I'm taking a minus b, all the elements present in b will be subtracted from set a. They will no longer be a part of my answer then. Subtraction means to eliminate them, right? So when we are doing a difference between two set, that means the set that that is subtracted from another set, all the elements of that very set should be subtracted from the first one. So that means that if set A has element 2, 3, 4, 5, 6, 7, 8 and set B have elements 1, 3, 5, 7. So we're going to subtract A minus B. We will be subtracting all the elements of B from set A. Now one thing is, set B is completely subtracted. So all the elements, whether they are repeated or not repeated, present in set B should be eliminated. That is, if we can see out here, there is one additional element in set B, that is 1, which is not present in set A, but still while using difference operator, we just subtracted this complete set from set A. Also we subtracted the elements that were present in set B from set A. If let's say someone wanted to calculate B minus A, so that means all the elements of set A which are present in set B are subtracted. Now as you can see, A is completely subtracted. Also the elements that were the elements of A that were present in B were also subtracted. As you can see that the final answer we got is only 1, a set which has element 1. That's it, because B is completely subtracted. 3, 5, 7 were also present in set A. What if we subtracted two sets? Out here, as you can see, that we have subtracted C minus A. Now as you can see that C has element 2, 4, 6, 7. The same elements are also present in set A. When we are subtracting A, that means we are subtracting A completely. Also the elements of A that are present in C are also subtracted, right? So in this case, when we subtract all these elements, we finally got a set which has no element in it. Or we can say we got a null set, which can also be written in this form, or the better form is to write a phi, or we can also represent it like this, that a set which has no member, because the result that we got is empty. Out here they have also calculated C minus B. Now C minus B, if you look at set C and B, there is nothing in common except element 7. Element 7 is the only member that is present in both the set. That is in set C as well and set B as well. When we are subtracting C minus B, that means we are subtracting B completely, and we are subtracting the element of B that is also present in set C. So since there is only one element present in one element of B is present in set C, so we have just eliminated 7, we have just subtracted 7, and the result we got is elements, a set that has element 2, 4 and 6. So moving on, we're now going to learn what are the complement of a set. Let U be a universal set, okay, and A be any subset of U. Then the elements of U which are not in A, that is U minus A, is the complement of A with respect to U and is written as A prime, or that means U minus A, or A power C. These are the possible ways of writing a complement. Either you write it by using A prime or you use A power C. So the main thing that we find in complement is difference, but this time the difference is from universal set, and since set A is a subset of that universal set, so let's see by looking at an example that how it works. So we have an example that there is a universal set which has elements starting from 0 till 9, and we have a set A which has element 1, 2, 4, 6, 9. When someone asked us to find out a complement, that is, we have written A prime, that means we are subtracting set A from the universal set, right? From the universal set, that means the elements that we got in answer are 0, 3, 5, 7 and 8. Since 1, 2, 4, 6, 9 are present in set A and they are eliminated, so the final result that we got is 0, 3, 5, 7 and 8. Okay, there is something that we need to know before moving on to another operator of set, that is ordered pairs. Now what ordered pairs are? Let's say an ordered pair is a pair of numbers x, y written in this form, particular order. The order pair x comma y is not the same order pair as y comma x, where x is the x coordinate and y is the y coordinate. Now why they have mentioned something like ordered pairs? That is because the next operation that we are going to learn requires ordered pairs, and since it is written that x comma y, if it is an ordered pair, it cannot be equal to y comma x. Since we write number notations when we do graphs and all, we write it as 3 comma 2 in bracket form in such xy form. So ordered pairs is a pair of numbers that is written in a particular order and is telling about some order, that x value, the first value that is written is on x-axis, the second value written is on y-axis. So let's see. Okay, so we are moving on to the Cartesian product of two sets. For that we need to know the ordered pairs first. So what is a Cartesian product? Cartesian product of two sets A and B, also called the product set, direct product or cross product, is defined to be the set of all points AB where A belongs to A and B belongs to B. It is denoted by A multiplied by B and is called the Cartesian product. Now as you can see, we have done operations like union, intersection, difference. So there is another thing in sets that we are going to work on, that is finding cross product or multiplying two sets. For multiplication of two sets, it is important to multiply two sets by using ordered pairs. Now these ordered pairs will be defining that which element belongs to which set. So let's just look at one of the example and find out how it works. For example, we have a set A which has elements A, B and C. Then we have set B which has elements 1 and 2. For instance, they ask us about A multiplied by B. Now you can see that A multiplied by B, they are all set, but the members itself are in the form of ordered pairs. They are in the form of ordered pairs because we cannot just multiply, we are multiplying it element to element as far as two sets are concerned. But what we are doing out here, that these two numbers are written, the multiplication of two sets is done in terms of ordered pairs. Now how it is done? First of all, since it will be a set, of course, so the first member is multiplying first element of set A with first element of set B. Now how it is written? It will be written in the form of ordered pairs, as it is mentioned in the definition, that it will be the set of all points AB. That means that set A, the element, first element of set A, that is A, comma, the first element of set B, that is 1. Now we are going to repeat it again with the second element of set B with first element of set A, that is A, comma, 2. Now since first multiplication, first element multiplication is done, let's move on to second element, B, comma 1, B, comma 2, then C, comma 1 and C, comma 2. So this is how multiplication between two sets is done, where the A, B, C are the elements of set A and 1, 2 are the elements belongs to set B. Let's say if someone asks us about B multiplied by A, so this is your homework guys, that you need to know how B multiplied by A is done. That's all.